which is on industrial electrical safety. The training which we've long anticipated and which was scheduled to commence today. So luckily, I'm so glad that yes, we are here and we are kicking off with this particular professional training. The training is industrial electrical safety. So like the name implies, it's all that has to do with industrial electrical safety activities. When you work in the industry, we all know that yes, electricity is virtually one of the main components of every industrial activities. Either you are in the electrical department or not, you at one point or the other always relate or deal with electricity. And we can't really overemphasize the importance and the extent to which electricity can be useful or can actually cause damage as well to industrial activities. Hence, industrial electricity is very, very important. That's electrical and target for instruments that are powered by electrical, then you have to look for the safety aspect of it. Hence, this training industrial electrical safety. Okay, so let me do well by introducing myself first. My name is Kennedy Sampson, and I'm going to be your host. I'm going to be your moderator of this training. So this training is scheduled to hold for 2 days, that is today and tomorrow. And trust me, you being a part of this class, you are going to find it very, very useful and very, very interesting. Because we have one of our very effective and efficient resource person who is going to break down all that this course industrial electrical safety is all about to the best of his ability. And trust me, you are going to enjoy this class. He's one of the best in the field when it comes to the lead speed, when it comes to passing on knowledge. He's actually one that you don't want to miss his class. Yes, I'm going to be introducing a bit, but before I go to introduction, I want to also introduce courses and what your expectation of this class. And tell us your name, tell us where you are joining us from, and tell us what you expect class is. Can we all hear me? I find it difficult to hear my voice.
Mr. Chukura, you can mute your mic, please.
Okay. Thank you very much. Thank you very much. And those who are joining us at live platform,
some people are interfering you, sir. Some people are interfering you. Some mics are on.
Very much,
Mr. Moderator. Some mics are on. They are interfering you.
Tell me where you are joining us from. Quickly, let's do that. And what your expectation of this training of this class is. So quickly, let us do that. Quickly, let's do that. Tell me your name. Tell us where you are joining us from. Do that for me in the comment section. Okay, so like I did explain, yes, we have our resource person who is here with us. But before I introduce our resource person, this training, Industrial Electrical Safety, is brought to you courtesy CUC Concept Training Company Limited. Yes, we've been into the field of training for a couple of years now. Yes, and we have many people who are on board in this class who have at one point or the other maybe participated in our training. And please, if you have been a part of our training before, maybe in any of our trainings before now, can you just give me, let me know in the comment section. Just give me a thumbs up, or you let me know in the comment section that yes, you have participated in our training before. Thank you very much, Yusuf Abdullah. Okay, Emmanuel Ojusi. Okay, thank you very much. So trust me, as a firm, as an organization that is into professional training, our goal and aim is to be able to ensure that yes, we have an effective and a productive workforce. We help organizations to be able to achieve this goal. And how do we do that is by bringing out or giving out some of these professional trainings on a platter of gold. You will agree with me that if you want to go for a professional training on industrial electrical safety or any related professional training, you spend a wholesome amount of money to be able to acquire such knowledge. But trust me, our organization, in part of our achievements or part of our goals, to be able to achieve our organizational visions, yes, we are bringing this training on board, and for you to be able to participate in this training for free. This training is absolutely free, and you'll discover that in the course of registration, you actually get your registration for free. So, and I want us to please tap into this opportunity that CUC Concept has given out and take hold of it. Yes, I do tell people many times when we are having trainings like this that learning they continue. You are not expected to get everything, the whole knowledge you require in this particular training. You have to do research, you have to study on your own, and I expect that at the end of this training, whatever resources or whatever materials that we give out, that you should please go back, re-watch them, re-study them in order to get better and do further research in order to help your understanding better when it comes to the field of electrical safety. This training is going to be a very, very interesting one. And trust me, we have a resource person here who is going to be doing justice to this professional course. He's no other person than Mr. James Faniyi. Yes, many people who have been a part of our training already know who I'm talking about. And when it comes to introduction, you always tell me to always skip the formalities and the like. So I would honor his request in today's class. And in a few moments from now, you are going to be hearing the voice of Mr. Faniyi. Just a few people have introduced themselves. I want to know where you are joining us from. I want to know what your expectation of this course is, and I want to know your name as well. Thank you very much, Funke Telma from Lagos. Thank you very much, Suleiman, Richard. Thank you very much. Okay, Mr. Richard is joining us for the second time. Thank you very much. Yes, it means you've been a part of one of our trainings before. Engineer Nielsen from Ebonyi, thank you very much. Suleiman Rudin, thank you very much for joining us. Is there anyone joining us? Oh, Richard Kofi from Ghana, thank you very much for joining us. Oguniyi from Abuja, thank you very much all for joining us. So please keep the introduction coming in. Tell us your name, tell us where you are joining us from, and what's your expectation of this course is. Yes, we are streaming live on YouTube. So for many people who don't have the opportunity to join this classroom link, so please feel free to use the YouTube link. You are equally going to be getting the same value, the same output of this training. Okay, so please let us do that. And please, I also want to reiterate, we do send invites to your email. So please, once you register, because we notice that many people don't usually use their emails. So please, once you register for a particular course, just always try to go back to your email for feedback. Yes, because I've been getting a lot of complaints that some people are saying they didn't receive the class invite, they don't have the class link. So please check your emails. You will definitely get the classroom link there, or any other information that we have. We do send them to your emails. Okay, so please, but however, we have actually dropped the classroom link on the WhatsApp group, so you can easily go there. Since we are going to be using the same link for both classes, I mean today's class and tomorrow's class, we are going to be making use of the same link. Okay, so please do utilize the link, and with that you can easily access or join in the class. Thank you very much, Mr. Joseph Felix from Maiduguri, or Data Christian from Ebonyi. Thank you very much. Okay, so the class rules are thus. Please, when you are joining the class, if you must ask a question, just signify it by raising up your hands. Then I'm going to call on you to proceed or to ask your question. But what we are going to do is, if you have any question, just keep your questions till the end of the class so that we don't interrupt the class at any point. Trust me, the resource person is going to give an answer to every of those questions. So we are here. Share your experience, share your challenges with us at the end of the class, and be rest assured that we are going to share of our words of experience with you on ways of how you can tackle or resolve such issues or challenge, or how you can forge ahead with them. Okay, so please, the classroom is just very simple. If you have any questions, signify by raising up your hand and you will be called upon. Okay, so without further ado, let's go straight into today's class. Yes, so you'll be hearing the voice of our resource person any moment from now. Okay, so let me try to bring him on board. All right, let me bring this down. Okay, so we are going to be doing something. We are going to be making use of one of our recorded classes to facilitate this class. Okay, so what I expect you to do for us is, once the class is ongoing, just try as much as possible to give us your own divided attention. The resource person is here already. He's here with us in class. So please rest assured that every questions, every comments that you have to be promptly attended to. So the next voice you'll be hearing will be that of our resource person, that is Mr. James Faniyi. Okay, so Mr. James, over to you, sir. Okay, please, is the class audible? Can we hear me? Okay, thank you very much. I can see a whole lot of thumbs up. Apologies. Let's try to bring this up. All right. Okay, so let's get back to the class.
I don't like telling people my profile, but if there is so much interested, you can find out. So I've seen people who are actually electrically inclined among us. So that's fantastic. That will make the training easier for me. And if you are not also an electrically grounded person, or you don't have the background in electrical, because a lot of people that saw electrical safety, they would think that, oh, it's only people that did electrical, and that would be a wrong mindset. When it comes to industrial safety, it is all encompassing. Industrial safety, affects you either you are working in a particular department or you are working in another department. In as much you gain access to the factory or you gain access to the industry, you enter from the gates. All hazards that are present are also what? Yours. So you can prevent them, you can guide yourself against them, and you can as well mistakenly or innocently or ignorantly expose yourself to those hazards. And that is why you need to have the knowledge of the dangers around. You need to have the sound understanding of things that could go wrong at work. Either you are actually interacting directly with some equipment or not. You need to really be aware. And it's not really, especially in this part of the world, I mean Nigeria or Africa, sometimes I don't blame employees, because when there's what we call induction, when you get a new transition, irrespective of your experience, when you are moving from a company to another company, transiting from one company to another company, if you like, write 20 years work experience in your CV, you need to be retrained. You need to still go through induction, because the environment where you are coming from is not the same with the environment where you are right now. So there might be some things that were not dangerous, or that do not really pose high risk where you are coming from, but here in our own company, maybe we have a history with it. Maybe a lot of people using a particular machine, they have had injuries or cases, of accidents with it. So we need to actually alert you also. We need to really give you another orientation, because there shouldn't be a situation where a worker or an employee will be involved in an accident, and then you begin to blame the company, saying that, oh, I was not told, I wasn't aware. For instance, let me come down to many of us, especially the electrically oriented people, those who are engineers. Because you have little knowledge of engineering or electrical, sometimes you tend to even do things that are against electrical safety. That I've seen people back then, that their own fan inside their room, they are the only one that can operate it. You dare not touch the switch in their room because they are the only one that can operate it. A lot of what expose, live conductors in the room of a so-called electrical engineer, just because he believes that he can always find his way. He can be careful, forgetting, days that he might be stressed or he might be forgetful about, what he was doing. There was something I saw which was very, very wrong with, electrical safety. And where I saw it, I was actually a lot disappointed. I could remember, my very first time of going to a power holding office, NEPA office, so to say. So, and reaching there, what I saw, I could not even say that I was in an office where they have what electrical work ethics. If you look at the conductors, the way conductors were left flying here and there on the distribution box that they themselves are using to supply their own building. It was left open, a lot of loose cables, a lot of twisting, joining that you dare not call another person who was not there or who is not actually familiar with that. You dare not call that person to come and troubleshoot that particular circuit or trace any faults. It's going to be in soup. I've had a situation before also where people do, connections. We have practice in engineering, electrical engineering, so to say. You say, okay, let's use red cable for live. Let's use black cable for neutral. It is not that if you switch the cable, it will not really there won't be supply. No. But it's because there is an ethics. There is regulation. There is, and all these things, they are for us to uphold electrical safety, such that if I am coming to troubleshoot, a particular connection, I should be rest assured that when I see red cable, I know that it's carrying live. When I see black, I know that it's carrying live. But, OYO is your case if you work like that, especially in this part of the world, because you still have to carry your meter. I've seen where, the red cable was coming, carrying live circuit, and then maybe the wire was not enough. They just join it with another black. And then by the time you see the output, you will see black. You'll not be wondering which one is live, which one is this, and all that. That's why you must always have your meter. So, enough said about that. I don't really want to be too deep into, the electrical thing and all that. So we may have people that are not electrically oriented among us. So let's get started on the training. Okay. Now, the first thing that we must know is that when it comes to industry, there are people who we call, qualified electrical workers, and there are people who we refer to as unqualified electrical workers. Who are the qualified electrical workers? I've seen so many here, perhaps, okay, that they said, oh, they are electrical engineer, or maybe they have the background in electrical engineering and all that. Now, people who have the knowledge, who have the work standard and the regulations guiding an electrical work in a particular industry, we can refer to them as qualified electrical workers. These are not just people that have ideas. These are people who have gone through trainings or who are actually professionals, understanding what electrical connection is or what an energized equipment is. Now, another thing, based on the electrical standard that we must understand, a qualified electrical worker may not be a generally qualified electrical worker. What do I mean by that? Somebody may be qualified on a particular equipment and yet is not qualified on another equipment, though both of them are electrical equipment, or they're actually using electricity. So you cannot say generally this person is just qualified. Take for instance, you are saying that somebody who can actually work on your socket inside your room, because is a certified someone that can work on electricity. So because that person can work on your socket, you then call him to come and work to come and climb poles on the streets. That would be definitely wrong. So somebody might be trained such that he can what? Climb what? He can walk at heights, you know, connect what? Cables from one pole to another, from one joint to another joint. And another person might be trained that domestically he can actually what? Troubleshoot and work with what? Electrical gadgets in the house. So there is nothing like generally qualified. There is only a relatively what? Qualified electrical worker. Now, who are the what? Unqualified electrical workers? These are the unskilled people. And in most cases, a trainee, okay, an industrial trainee can also be referred to either unqualified or qualified. He is only considered qualified if he is working under a supervisor who is actually what? Monitoring what he's doing. I could recall my Dangote Academy training. I went through Dangote Academy training, and I was so lucky to be among the first sets that entered into that training. And because of my passion for power, I actually chose electrical because we had a lot of options. Now, for the first few months in the training, we will go through the theoretical aspects in the classroom, and then they take us to what? Dangote Obajana cement plants in Kogi State. Now, anytime we are working, all of us were actually attached to what? Indians. Okay, we're working with Indians, and they were actually what? Saddled with responsibility to train us. Now, the training is that sometimes they may not even allow you to actually do any connection. For a while, you have to keep watching. You know, you keep watching what they are doing. At a point, they can give you what? Flyer. They say, okay, twist this together, take this cross to never do this. At that point, you can't call us qualified electrical workers because we are still under what? The supervision of someone. You can't work on your own. Anything can go wrong. And that's why electrical safety is very important. Electrical safety can lead to what? Death just within what? A microsecond. Electrical safety is so important to the extent that if you know how many lives, you know, that electrical accidents, you know, on job are taking, okay, if you know how many lives that these there was a statistics of this, you know, being done, that across industries, every day, a life of an employee, you know, across industries, every day, a life of an employee, at least a life of an employee is being lost due to electrical, you know, accidents on the job. So you can imagine that is every day, even as we are talking right now, today, if you do your statistics all around industries, across industries, you must find out that what electrical, you know, faults or electrical accidents or electrical hazard has taken what or claimed a life of an employee. When you make mistake when it comes to what electrical faults, you can actually lose your life and at the same time take many lives with you, along with you. Mechanical faults or other, you know, interactive or physical faults or safety, yes, they are also dangerous, but we have seen some cases where people put their hands inside what a rotating machine, they just lose their arm. Maybe they lose the right arm, the person may still stay alive. But if it comes to electrical, you may not even live to tell the story. You won't be amputated in most cases. It's not like you are going to be you are going to lose one hand or lose one eye. In some cases, you know, you lose life. And that's actually what the extent, you know, of the dangers that we have what in electrical faults. So when we talk about qualified and unqualified electrical workers, you must know where you belong. That does not mean that you are not at risk, whether you are qualified or unqualified. But what we are saying is that what if you are not qualified, the only, you know, thing that you bother your mind with now is how do you protect yourself against electrical faults or electrical hazard. But if you are such a person that is qualified that you interact with it, yes, yours also is also a question of how do I protect myself when I'm working on an energized equipment. So these two things are very, very important. You need to know where you actually belong. We don't encourage people who are not trained to work on, electrical equipment to just say, oh, I'm experienced, I can do it. That is against safety rule. But even you as a mechanical man, on the equipment where you are working, of course, it's going to be electrically energized. So you need to be aware of the dangers, and you need to learn what to do when the dangers also arise. That's what we are talking about. So let's move very fast. You need to familiarize yourself with the general requirements of the standards. Okay? You need to identify common electrical hazards. You need to understand the definition of electrically safe work conditions, recognize electrical equipment defects and hazards, understand basic wiring design and protection, and identify wiring methods, components, and equipment for general use. Don't worry, the material is going to actually be provided. So if you are not actually following with what we are actually displaying, there are so many things, because we are not here just for theories. I'm actually here for us to actually have the practical views of what we are discussing. Now let's look at causes of electrical accidents. What are the causes of electrical accidents across industries? Now the first one I will be discussing is unsafe equipment and installation. There are so many equipments that, due to poor maintenance, they may actually become unsafe for you to use. When we are using the word unsafe, we are talking about perhaps they are not adequately maintained. Back then in some industry, I will not be mentioning names of companies, there are some times that employees who supposed to maintain a particular machine might actually forget. Okay, they might forget. There are some machines that every 10 days, every 15 days, okay, that you need to actually maintain them. So sometimes they may actually forget, and when you do this, just know that you are putting the life of the person working on that equipment, you are putting the lives of those people, you are putting it at risk. Because interacting with that machine will now become dangerous. It will be termed unsafe, because there is an unsafe, maintenance culture already, that you as a person who was actually in charge of maintaining that machine has already promoted. So you need to know that from unsafe equipment and installation, you can actually have electrical accident. These can actually result to electrical accidents. We also have what we call unsafe work environment. Unsafe work environment means that if we are working, on a day that it does not rain, that environment may be safe. But on the day that it rains in that environment, it may be unsafe for us to work in that particular environment. If you are working, and the land or the ground or the floor where you are working is wet, that has become unsafe work environment for you. Meaning that there are dangers all around. And if you are also working with an unsafe work practices, what are the unsafe work practices? There are procedures across industries, and every industries have their own procedures peculiar to them. That if you are going to work on a particular equipment, these are the process and procedure that you need to follow. So when these three things, these are the three causes of electrical accident. Number one, I mentioned unsafe equipment and installation. Number two, I mentioned unsafe work environment. And number three, I mentioned unsafe work practices. All these, result to electrical accidents. Now look at the list of unsafe equipment and installation. What if you have faulty insulation? If the insulation, of the particular device or equipment that you are using, if the insulation has been broken, Now, what do we call insulation? For the sake of those people that are not electrically what branded, insulation is those things that you see as rubber. You can call it rubber, okay? That actually what protects, you from directly touching the conductor. So it is the insulation material that we refer to as insulator, okay? So we are talking about faulty insulation. If you have experienced this before, there are sometimes that if you forget that what the plier that you are using has already had a cut or a breach in its insulation, you may actually receive a tingling feeling, like a tingling sensation when you're working on electricity. To just bite you a little, okay? And then you will see that is because you are using a 40 watt equipment. Now, I also had another experience back then when we were supervising the Ibese cement plants. That's Dangote Ibese cement plants. I was so lucky that when they were building the Ibese cement plant in Ogun State, part of us as Dangote academic or academy candidates were actually used to also supervise the installation of the electric motors and other electrical gadgets. Now, if an electric motor is of a particular kilowatt, and you want to actually connect the earthing of that electric motor, there are some of them that you can connect the earthing cable to the body of the motor, and there are some of them that you can actually take the earthing cable to the ground based on the rating of the electric motor. At least anything from 50 kilowatts upward, you should be able to connect the earthing cable directly to the ground so that it can be saved. So these are practical explanation that you can have for the faulty insulation. What about improper grounding? I've mentioned that. Loose connections. Now, this can also cause issues. When there is loose connections, and that's one of the things that the electrical people do during maintenance. They have to retighten all the connections. They have to be sure that all the connections are firm and tight. Because if this is not properly done, there might be spark. And in some cases, we call it arcing. Okay, there might be spark. Let me show you some of those the pictures to all those things. So you can see loose connections. Let me get you a picture of spark that you can actually feel when the connections are not tightened enough. Okay, I think I should have one of those pictures here. Now, if you can hear me clearly and you are in tune with me in this training, either you're on YouTube or you are with us on Gmail, just go to the comment section and put "I'm with you." I want to be sure that I'm actually training people here. So you can see this. So this is a loose connection. Can you see this image right now? This is a loose connection. So you can see this is a loose connection. It is not properly tightened. Okay, and then the wire may actually touch. There may be live cable touching the neutral cable. A lot of things. It will actually touch even the body of the equipment, and then that might actually result to a fire incident if not properly controlled. So if you are with me, I want to see you typing "I'm with you." I'm with you. I am with you. I am with you. Thank you so much. Thank you so much. That's Chidima. Is Chidima an electrical engineer? That's fantastic. Now let's continue. Defective parts. Okay. Are there some part of the equipment that needs to be replaced, or that maybe had been repaired before and they are supposed to be replaced? Most of these things happen in industry. Sometimes, because of the corruptions, there are some part of the equipment that they will tell you, "Oh, replace this equipment." But because the person in charge wants to manage money, he will carry the old one, repair it, and then install it back, instead of him to buy a new one and replace. It does happen a lot. And you that you're working on the equipment, you don't know that there is a particular part of that equipment that is already defective, that is not working properly. this can actually what? Become an unsafe equipment, okay? And then it can result to an electrical what? Accident. I've mentioned ground faults. Unguarded live parts. What about unguarded live parts? Okay, let's see some images of that. Unguarded live parts of the cable. You know, when we say guard, there are some equipment that the guard is just to separate you, you know, from the part of the equipment that can give you a shock or that can result to an electrical accident with you. Okay, these are what guard. Look at this cover. Okay, this cover, you can see that this man, before he's actually what? Touching the switch, he raised what? A particular guard. He raised it off. This is a guard in case if there are what? Electrical faults or whatever that may actually occur here. This guard is actually what? Protecting. You know, is interfacing between you and the machine. Okay, there are so many other, you know, fantastic images that you can see with what? Guard, okay, being used. Okay, so when we move on, if I see any of those images, I will actually what? Bring that up also. So we have unguarded or live part. If the part is not what? Guarded, definitely the equipment become what? Unsafe. Underrated equipment. What about underrated equipment? When you have some equipment which happens a lot to a lot of people who believe that they have experience, you just look down on some equipment. You underrate them. This one cannot kill me. What can happen to this one? This one cannot kill me. But it does happen. As much as small as your phone is and the voltage in your phone, there are a lot of people who have not used phone, you know, safely before and plugging their phone while it is actually what? In use. Okay. And then there are, you know, many lives have been lost due to that. And there is a lot of people that had what? Terrible story to actually what? Tell about that. Okay. So let's look at this. What are the unsafe, okay, work environments? Unsafe work environments. What makes the work environment unsafe? When you have flammable vapors, liquids or gases, the environment becomes unsafe because any little spark, you know, can result to what? Explosion, can result to what? Fire incident. When you have a corrosive atmosphere, okay, that's an unsafe work environment. When you have wet, I've mentioned this before, wet and damp locations, this is also what? Unsafe work environment. All these can actually lead to what? Electrical what? Faults, or they can lead to what? Electrical what? Accidents. What about unsafe work practices? For example, you are working on an energized equipment. When we say energized, we are talking about what? Equipment that is still plugged. This is so common. And mind you, you have to, you know, ensure that your safety is prioritized. Because I've seen a lot of people, and I've heard about a lot of people, you know, who actually wanted to impress their boss, but they lose their life in the course of, you know, demonstrating loyalty in a stupid form, in a stupid way. How is your loyalty? How can it become stupid? It becomes stupid when you are putting your life, you know, at risk just because you want to work on an equipment. What is the normal practice? The normal practice of electrical safety is that, you know, you should do all you can to ensure that the equipment is what? De-energized. De-energized means that what? You remove what? The power supply from it. When you are working on any equipment, it should be a dead equipment, except somewhat some tiny cases. There are some tiny cases, exceptions that we normally have, where you may not have to what? De-energize what? The equipment. But there are other procedures that you must, you know, undergo, which in the course of this training is going to be mentioned, for you to actually what? Guarantee what? The safety of the person working on the equipment. But the first thing, the foundation is that what? Every electrically what? Energized equipment must be what? Unplugged or de-energized when you want to work on it. So failure to de-energize electrical equipment when what? Inspected, or when you are working on it, that is an unsafe what? Work practices. I've had a lot of people who testify to this. I I have a friend back then in the academy, so he was working with his boss and his Indian boss. And normally, if you have interacted in the electrical in the industry before, when you want to talk about some equipment, let me share a whiteboard for us to see what I want to actually demonstrate. Now, there are things that we call push button. We call them push button. You see them, okay? Sometimes you see green, red, you see a big one, which is an emergency, okay? And then let's say the machine that you are operating is here. So this is what happens on the field. This is the switch, this is the machine. And then you are the personnel that want to perform maintenance on this machine. The requirement is that you must have gone to electrical department, okay? Electrical department. Now, what will they do in this electrical department? You go and obtain what we call line clearance. Line clearance is that you are telling electrical department, I want to work on this so machine. Please, I need you to disconnect this machine for me for the period of time that I will be working on it. That is the normal practice. You see where this knowledge is very important for even those people that do not have electrical background. Because you must not work, you should try as much as possible not to work on an energized equipment. But in most cases, especially in our industries, especially in this part of the world, there will be some proposals which would actually want to force you that you can manage now. Don't you have flyer? Don't you wear your glove? All these are not enough for you to say you want to go and work on an energized equipment, which you're supposed to take line clearance for. Or you know that at the control room, because there's always what we call control room, especially if you are working in an automated plant, just like a Dangote cement plant. The plant is fully automated. So the control room always starts the equipment, every equipment, they can start it remotely. That is, without leaving the room where they are, they can start it due to programming. They can start it on the system and say, this particular machine should actually start. And it will start wherever it is on the field. Their own is just to press start button on their own computer. So in the control room here, they can remote start this particular machine. So my friend and his Indian boss, they were working on the machine like this. And if I could recall, the machine was 660 volts. I'm still going to explore that. For those that may not know what we are talking about, when you're talking about 660 volts, that's even more than the 3-phase connection. Okay? At least in 3-phase, you should have like 415, or maximally, let's say if you have a very good supply, let's say 440, but 415 is usually the actual practice. Sometimes you can have less than that, but if you measure 415. So now imagine somebody working on the one that was 660 volts. So he told the Indian man, because they are working on an electric motor, they want to actually perform the maintenance. And they have to open the terminal. Opening the terminal means that you are going to be using plier, you are going to be using spanner directly on the conducting part of that machine, electric motor. So he told the Indian man that, please let us go and take clearance. But the problem was that the Indian man supposed to have carried out maintenance on that machine based on the company record. But he missed the particular day. So legally, he cannot go back to electrical now and say he wants to take line clearance. They will ask him, this machine is supposed to have been maintained last week. Why didn't you do it? It's going to become a case on him. And because of that, he wanted to play a smart one. And he himself knew the danger in it. So he was not doing the job. He was just standing and using mouth to control this, my friend, that he should do this, touch here, touch there. And that one was saying that, sir, where is the line clearance? He said, no. If you have worked with them before, no, you line clearance, no need now, you do fast. We live here. My friend also told him, okay, there is a provision for emergency switch. This emergency switch on the plant, when you press it down, the control room, they will not be able to start that machine. What they will be seeing on their on their lab, on their system is error until you come back to this place, okay, to go and release this emergency switch. So he told him, okay, let us put emergency switch. The Indian man also knows that there will be question on who put the emergency switch, because the control room, they are going to say that they had a delay of 5 minutes to start that particular machine. And that's going to be an issue. And somebody must answer that question. So he also denied him. He said, no, you cannot put emergency switch. You should just quickly work on the electric motor. Behold, luckily for him, he had already finished the maintenance. He was just covering the terminal of the electric motor. And that is how the machine started like that. He told me of his experience that he nearly even slapped his boss. Just imagine if it was when he was using spanner on that particular conductor. The story wouldn't have been the same like I'm talking about today. It would have been a sad story. But luckily for him, he escaped it. That can be you, that can be anybody. But what is his right? He has his right that he could have maintained his stand that I cannot touch an energized equipment unless we go and take line clearance. I've heard of funny story, and they are not really funny, they are sad story of NEPA officials, okay, who try to work on a live pole, you know, high voltage, where they're supposed to call office and say, oh, take down this particular line, we want to work on it. But because they have also missed the maintenance, you just see that it will be somebody they will use as a lab rat. They say, oh, you are the junior staff here, you go. And you also, you want to maybe you have learned, you have been trained, they will tell you that, don't you know anything? They will check you like that. And you want to show that you know your job. You also want to prove some points. And stupidly, foolishly, the person moved down there. I had a story of a man whose wife just gave birth, was a NEPA official. This person is known to me, is known to our moderator, Mr. Kenny. So I think I had that story from even Mr. Kenny on the day that we actually were discussing about, you know, safety and all that. We're just chatting about it. So he told me of his about this friend of his. He was a colleague to him, okay, and then he was a school colleague back then in school, and a very promising guy, okay. The wife just put to bed, you know, very small baby. So he was a NEPA official, and then they check him that, man, come on, climb this thing. When I was like you, I used to do this, I used to do that, and he climbed, and that was it. The connection was actually taken up at their office, not knowing that somebody was working on the line, and he died instantly. That is an instant death, and that's why electrical is actually very, very, electrical accident is very dangerous. You know, it does not give you second chance in most cases. Now, what happens when you have use of tools or equipment too close to energized parts? Okay, look at these connections. You know, we're just using this as an example. Look at this overloading. Okay, so that's what we mean by overloading circuits. How many of us actually still do some connection like this? This can result to, if you go to bed with this, anything can actually go wrong. And also in plant, also there are junctions that are actually usually being overloaded. Now let me show you some images of line clearance. Okay, you see people working on. Now what they are doing here, okay, if you have worked on all these kind of breaker in the company before, so they will bring you to this breaker, okay. They are probably tracing the reading or tracing the supply. They have to bring this down, because most industries, you know, I don't know where you work, you see this kind of breakers. All of them have a machine on the field that they actually supply. So if you are actually working on a particular machine and you have to take line clearance, you as a mechanical man or whatever may be your department, you have to follow the electrical man to this breaker here. In your presence, you must take it down, and in your presence, you must actually put the line clearance. I'm going to talk about that when I'm talking about Lotto. So let's move on, because we do have a lot. Okay, now let's look at electrical safety model. What is the model for electrical safety? The model that you need to actually follow. We're talking about the pattern that you must actually follow for electrical safety. Now, what is the pattern? The first thing is that you must learn to recognize hazards. It becomes a problem when you don't know that something is wrong. As an employee, either you are an electrical worker or you are a mechanical worker, or irrespective of your work department, even if you are working in bank, when you see what is wrong, you should know what is wrong. What is the definition of an hazard? An hazard is anything that poses what? A level of what? Risk. Okay? To either life, property, or environment. That is an hazard. An hazard is anything that poses a level of risk, okay? Anything that poses a level of risk, okay? That poses threats either to life, okay, to environment, or even to the equipment itself, okay? So anything that has potential to cause harm is an hazard in the industry. So now, talking about the electrical hazard now, anything that has a potential to cause electrical accidents, anything whatsoever that has a high what, that has a potential to cause electrical accidents, that is what an electrical hazard. You need to learn how to recognize them. That's why we say that to avoid injury or death, you must first understand and recognize hazards when you see one. Now, when you begin to see, some of these images, okay, that I have been showing you, look at this. When you see something like this, you should know that what? This is what? An electrical hazard. For crying out loud, how can somebody connect cables like this and leave them? No tape, no insulation tape, no covering, and they are exposed. That is hazardous. So when you see this as an employee, either you are working in the electrical department or not, it makes sense, okay? It makes a whole lot of sense for you to be able to see this and say, oh, this is wrong. This is against safety. You need to actually what? Recognize it. Look at this connection here. What do you think that is the problem? Okay? There are many people that when the plug is bad, they remove the plug and they start connecting the cable directly into the socket. That is against the ethics of electrical safety. That is an hazard. When you see something that is wrong, when you see danger, ability for you to recognize that danger is what we call recognition of hazards. So electrical safety starts with you becoming aware of what is wrong. Okay? You need to see it and you need to identify it. Look at this. This plug is burnt. Okay? When you see what is wrong, you need to recognize it. When you see bent poles, some electric poles that are already bending, towards the ground, you know that oh, this is wrong. This needs to be corrected. Okay? When you see somebody walking like this, okay, let's see if she's using electrical shield. Okay. When you see somebody that is working on electrical, equipment, and perhaps is going to be twisting some conductors together and is not putting on his glove, it is very, very wrong. So look at this man here. That's a very good practice. Let me zoom it for you to actually see the image. Okay. It's a very good practice. Okay. You can see is it's an electrical goggle that's protecting his eyes against hacking. He's putting on his helmet. That helmet might not be due to mechanical impact. There are sometimes that people's head get in connection with live cable when they are working, when they forget themselves. Especially if it's a particular joint box where you need to bend, be at a particular elevation or angle of depression to the equipment that you are working on. You need to protect your head, okay? Because you can easily forget yourself. So you need to recognize hazards. The next thing that you need to do is for you as an employee to evaluate the risk. Oh, this thing is dangerous. How dangerous is it? That is the evaluation of the risk. Oh, this thing that I'm doing is risky. Let me now evaluate how risky is what I'm doing. What could happen if I get entangled with this electrical conductor? What will happen to me? Will it just be a shock that I will receive? Will it be a total electrocution? Will I actually suffer burns? All these things are evaluations that you need to do. Then, now that we now know the hazards and we have evaluated the risk, okay, then the next thing is for us to control the hazards. And there are so many things for us to do to control the hazards. There are policies, that's administration control, okay. There are cases of producing guard on the machines, such that the part of the machines that can actually open the worker to electric shock or electric fault or electric accident can actually be protected and covered. And then there are what we call PPE. So we'll look at that in this subsequent slides. So let's look at the hazards. Recognizing the hazards. What are the most frequent electrical hazards or injury across industries? So let's look at this. Contact with power lines. That's when you touch the power cable that is actually supplying a particular equipment. I hope you are with me. Anyone in the house?
Yes.
All right.
I'm with you, sir. But nothing is displaying.
No, you are not seeing.
I'm not seeing the screen, sir. Nothing is displaying.
Oh.
You scroll it up or down. Yeah.
Is there anybody here that is actually seeing my screen? Who is seeing my screen here?
I see.
I'm seeing your screen.
Now, when you scroll it, you will see it.
Okay. Can you see my screen?
Yeah, the screen resolution is very small. The view is very small.
So, we are looking at the frequent causes of electrical injury or death. The first one here is contact with power lines. I've mentioned that. I said when you are touching, or when you come in contact with the power cable. That's the cable that is actually supplying a particular equipment. Lack of ground fault protection. There are some times that, what we call earthing. Earthing is, I have an equipment like this. Okay, let me show us in the whiteboard. You can have an equipment, okay? If this is our machine, because the ground, that's the earth, is a good conductor of electricity, there are sometimes that the body is actually connected with a cable, with a conductor, okay, buried in the ground. That's what we call earthing. So what happens when there is faults in this? When this actually fails, because it can fail. That's what we are talking about. What happens when it fails? That's what we are talking about. Ground fault protection, okay? Another thing is parts towards ground missing or discontinuous, equipment not used in manner prescribed. Now, there are some times that, especially in some industries, it's so common. Every manufacturer of equipment will tell you how to use it. And you will agree with me that most of us in this part of the world, we have some poor maintenance culture. Most of the faults that occur on machines are due to poor maintenance culture, because we are not properly maintaining those machines. So when the equipment is not properly maintained according to the prescriptions that the manufacturer has given, then there is going to be a lot of hazards. So you can actually recognize that as an hazard. Improper use of extension and flexible cords, that is the connections across the plants, when they are not properly, when you don't use them for what it's actually meant for. Take for instance, you can't How many of us connect? How many of us plug? Please don't lie to me. Okay, I need somebody here to tell us, how do you differentiate a 15 amp socket and a 30 amp socket? Is there anybody here that can try?
Yes. Yes.
Okay. Okay. Ali,
Yes.
Ali, you go ahead. Ali, you please go ahead. Tell us the difference.
Please signify if you want to speak. Signify if you want to speak, please. Okay. Bolaji Adepoju, you can unmute your mic. Bolaji Adepoju.
Okay, sir. Good evening, sir. I think to differentiate 13 amps from 15 amps. Number one, all the electrical appliances are power rated. From their indication, we can see that. And from physical appearance, 13 amp socket is usually in a rectangular, I mean the pin mouth. Why the 15 amp socket usually pin in a cylindrical form? That is the two way I can take to differentiate. Number one, by indication, and then number two, by the physical appearance. Thank you.
Yeah.
Okay, thank you so much. Now, what I want to ask now is that, how many of us plug our, I'm going from industry, we are cutting across. Okay, I'm just using what anybody here that does not even have electrical background will actually relate to it. That's why I'm coming low to those illustrations. How many of us plug ions on a 13 amp socket? You risk it, like for a while you use it. Is there anybody here?
Yes.
Okay, you do that. Who is that?
So Jola Iwaju.
So why do you do that?
I don't really know it.
At times when you are in a hurry. Okay. Now that's what I'm talking about. Okay. So when you load, when you load a particular equipment, that its current rating is more than the source, then there is a problem. Okay, there can be a problem. Okay, and if you are lucky, it might be that you just replace that particular source. And if you are not lucky, it might result to something else, especially if you are not the one handling it. If it's somebody at home, or if it's somebody in the industry or in the department that is actually interacting with that machine, you understand it anytime you want to use it. You are always careful with it because you know that what you have done on it is dangerous. But that person might not be so careful. That's what we are talking about. So that's why this play is talking about improper use. Careful planning of our safety procedures. We need to know that this also helps in reducing the risk of injury. When you plan the safety procedures, when you have a careful planning, towards the safety procedures, then it can actually reduce the risk. And when there is a decision to use Lotto, I'm going to be explaining this Lotto later. When there is a decision that a company say, oh, we are going to be operating Lotto on any equipment that anybody wants to work on, then this also facilitates electrical safety in companies. Electrical hazards. What are the hazards that may result from electrical faults? Explosion. That's the very first one. There can be explosion due to electrical faults. Because you should know that electricity provides ignition. Okay, when you have a flammable atmosphere, or when you have explosive mixture in the atmosphere, they just need an electrical spark, just a little spark, and then you have everywhere engulfed with fire or exploded. Okay, there can be fire incidents. Unlike explosion, you can also have fire incident due to electrical faults. And in fact, if you have undergone fire safety before, because it's part of the curriculum of this course, fire safety, we are going to talk about it. Fire safety will show you that one of the dangerous type of fire or class of fire to fight is the class of fire that is caused by electrical, faults. Because aside the fact that you are fighting the fire, your life can be in danger. You can also be exposed to what? Electrocution. You can be exposed to what? Electrical hazards, even while fighting a fire that is caused by what? Electrical source. So that's what we are talking about. So it can be overloading of the circuit that cause that. It can be excessive current flowing through a particular faulty wire. I've seen a situation before where, you know, there was a spark just from a source, and the fire started tracing the wire. From that place, the fire started burning, and it's usually very fast. Fire being caused by what? Electrical source is usually very fast. If it will burn the whole cable or burn the whole equipment, it's going to what? Take, you know, a minute. Everything is what? Everything is burnt to ashes. Arc, flash. For those who are not electrically what inclined might not know this, but I will show you what arc flash looks like. Okay. I will show you what arc flash. Okay, you see it like a spark. Okay. So we call it arcing in most cases. Okay, look at this. This might be due to what? Arc flash. So what you will see it with, let me give you a very close way for you to notice it. Sometimes when you try to what? Operate your switch, when you press that switch, you see something like a whitish light discharge, you know, like a spark of very whitish what? Light discharge. That is what? Arcing. Okay. When when the electric current flows through what? A different path other than what? The path that has been created for it. That is what you have what? Arcing. The electric current leaves its intended path and travel through what? Air from the conductor to another. Then that is what we call what? Arcing. So it's just like let me demonstrate that for us to see. If I have a switch, okay, if you have a switch, normally the connection is that if current is coming here, okay, current is entering through here. If I press this switch, the path that this current is supposed to flow through is supposed to flow through this switch. But what happens, okay, when the current jump through the air and just jump at this place? What happens? That is what? Arcing. So you can see the way it comes, like an arc. This is the shape of an arc, okay? So that is why we call it what? Arcing. It will come like an arc. This is where the current is supposed to go straight like this. But maybe this line is already what? 40, or is actually small to the what amount of current I want to pass. You just see the current will just jump with a flash of light, okay? Just like your lightning, it will jump and it will form an arc like that. That's why we call it what? Arcing. Okay? It's not a deep electrical course, it's just an inclined. I would have delved deeper than that. Now let's look at the evaluation of risk that we are talking about. You should know that what? Not all risk is equal. All risks are not what? Equal. I'm going to show us a particular diagram here. All risks are not equal. Okay. So when you're analyzing the risk, okay, of the electrical fault, you have to analyze it with the probability of an injury occurring. And if this injury should occur, what would be the severity? So in other words, what we are saying is that what? Risk is calculated by probability multiplied by what? Severity. Okay. Now, what are we talking about? What is the probability that this equipment will result to what? Electrical what? Accidents. So how to calculate the risk? You need to first know the probability. Take for instance, a well-guarded electrical equipment. We have a low probability to an electrical equipment that is not what? Whose connection is not what? Guarded. So if I open all the connection and the wires are like this, okay, I've just increased the probability of electrical accidents. So there will be probability. Now, sometimes probability might be low, but you now ask yourself again, eventually, if this electrical accident actually occur, How severe will it be? Severity will not be telling you. Will that be what? Just a shock? Will that be just a shock? Will that be what? Burns? That's the question that severity will be answering. Okay. Will that be, electrocution? Will there be contraction of muscles and the likes? So you begin to answer what? All these questions. That's when you test out what? The severity. How severe will it be? That's what we are talking about. So you identify the hazards that could lead to injury or that could lead to what? Death. That's what we are talking about. You have to identify them. This can only cause injury. This can lead to death. So it will help you to know how to actually safeguard the equipment, or protect the employees, or protect yourself against electrical accident or electrical fault. Okay, so look at this diagram. I just hope we can see this. Now, this is the evaluation of risk. This is what you will see in most safety analysis when it comes to risk assessment or hazard risk assessment. So you will see this diagram. Now, this column is dealing with probability. You can see where I put the red. You can see probability there. This one is dealing with how severe will it be. So what is the level of the probability? We have low, we have medium, we have high. What is the level of severity? We also have low, we have medium, we have high. So when you take a particular hazard, that particular electrical hazard now, or any hazard whatsoever, anytime you are doing a risk analysis or risk evaluation, you have to get what is the probability. Is it low? Is it medium? Is it high? And what is the severity? If it eventually occurs, how severe will it be? Will it be low? Will it be medium? Will it be high? So that you will know, okay, what to do, okay, and how to actually control it. Take, for instance, now, look at this practice. Now, this one now. This person want to replace a 120 volts, want to replace a 120 volt AC equipment. You want to replace it. And then, when the analysis of the risk was actually done, it shows that the probability of having electrical faults or electrical accidents from this is low. So you can see that it falls on low for probability. It also falls on low that if it eventually occurs, how severe will it be? It also falls on low. So when you plot this, you see that it is low probability, low severity. And that's the kind of risk that you can take. You can take this risk because eventually we can see that it's very rare for electrical fault to occur due to this. Electrical accident to occur due to this. And even if it occurs, the severity is low. So then the company can say, okay, fine, this kind of job, perhaps the employee will just wear PPE and then go ahead to do the job. But look at this. The one of repair of 230 AC motor. Okay, what do you see here? You see that the probability follow. Can we see my screen? Can anyone see what I'm doing?
Yes, we are seeing.
Yes, your screen is not visible, sir.
Yes. I can see it.
If you trace probability, you see that the probability of the electrical fault here, the risk from here is on medium. And then you will see that the severity is also on medium. So you will see different color. The blue color you are seeing here means that anyone that fall under low probability, low severity is safe. You can work on it. Now the color was changed when it comes to probability being medium. The severity is also medium, because here now we know that something may actually go wrong. It has already fallen on the medium. So here we have to take even though we are going to go ahead with this kind of job, there must be a lot of things being put in place. The line clearance, the PPE, the procedures, everything must be put in place to safeguard the life of the people that will work on this equipment. But look at the story. The story will change when you come to what? Installation of 7.5 kVA transformer. Now we now did what? The risk evaluation. The risk is high. Can you see that? It's coming from high. And if eventually what electrical fault should happen here, what is the severity? The severity is high. This kind of job, don't try it. That's what we are saying. So you can see how risk evaluation will expose the kind of job that is dangerous. So it means that if we are going to work on this, we have to de-energize it. We can't work on this 7.5. We can't be doing the installation when the supply is actually on. That's what we are talking about. Evaluating the risk here shows that what the risk is actually what high. You can't be working on a live cable that is going to be feeding 7.5 kVA transformer. The probability of electrical accident is high doing it. And if it eventually what occur, probably it will lead to death, not even injury, death. That's why what the severity is also high. So that is how. So you can always plot that particular that you can always make that practical. And that's what I'm going to actually demonstrate now. Is there anybody that wants to volunteer? I need somebody to volunteer. You will give me, let me tell you what you are going to give me. Give me a particular industrial related electrical work. Okay, you can give me like 1 or 2. And then we are not going to try to plot it. Can it be done when the supply cable is energized? Is there anybody?
Olofin Sola, I can see your hand. You can unmute yourself. Olofin Sola, are you there?
Okay. Good evening, I'm here.
Just
the one I want to talk is when we have 7.5 kV compressor. Oh, okay.
Okay. 7.5.
The rating 3.5 kilowatts electric compressor.
3.5 kilowatts compressor. Okay. So, do you have any other one? Do you have any other one?
And 10 kilowatts.
Okay, 10 kilowatts.
Yes.
Now, let's look at this as you want to perform maintenance. Which of them, if you want to perform maintenance, so we are looking at them being what? Live cable. So let me zoom this now. Where does it come? If there is supply, if the supply is on, where will your 3.5 kilowatt compressor fall on? Under probability. What's the probability of electric accident on it when it's energized?
Looking at it, I think
medium
or high?
It's medium. Medium.
You have worked on it before.
Yes.
Medium. What about the severity? If eventually electrical accident occur on it, will the severity be low? Will it be medium? Will it be high?
No.
What can happen?
Medium.
Why do you say medium? It cannot kill.
Its probabilities. Yes.
It cannot kill.
It's medium. The severity will be rating.
Okay. Severity will be medium. Okay. But what is the probability?
It can kill 3 phase. 3 phase, it can kill.
2.3 volts can kill.
So what is the severity? The severity is high.
If it can kill, the severity should be high.
The severity should be. That's what I'm just being practical with you now. You need to analyze the job that you are doing and know I'm actually showing you how to do your own risk evaluation. This is a practical class. You need to be able to evaluate so you can see now others are contributing because it can kill. It's 3-phase. What we are talking about is what? 415. Especially if you now have it complete. If it's not the one that drops to 380 like some that you are going to use your meter is going to be showing 380 or so. If your 415 is complete, just imagine 415 flowing through you. Because I know for you to perform the maintenance, you have to what? Use your spanner, is that also? On the terminals and all that. So the severity is high. But what is the probability? What is the probability? The probability is medium. So that means that what is going to be here. So look at it. So if you bring it here, your 3.5 kilowatts will be here. So if you trace it, probability will show that what? It is from medium. Can we see this? Probability is from medium. Can we see this?
Yes, go ahead. Yes, go ahead. We can see it.
The severity is high. So look at what is fallen. So you can always plot like that. I'm just showing you now that what? It doesn't have to be medium. It doesn't have to be high. One can be medium, the other one can be what? High. One can be low, the other one can be what? Medium. Either probability or severity. Now, where will you put your 10 kilowatts? What is the probability? Anybody can help. What will be the probability on 10 kilowatts?
That's high. Mr. Charles, are you there? I'm hearing your voice.
Yes, sir. I'm here, sir.
Okay, please contribute.
So
the probability will be high. The probability will be high.
It will be
high.
10 kilowatts. It will also be high.
Okay, so your 10 kilowatts
because it demands a higher voltage.
Okay, that's it. Yes. So this kind of equipment, you need to de-energize it.
Yes.
You need to de-energize it. You can't work on a live cable like this. Okay. How many of us work on our electric socket at home, even without switching off? Is there anybody that has done connection on or socket?
Yes.
Okay. Yes, no, now look at that now. Look at that now. You can plot that here, working on sockets, your socket at home now. So what will you give that? What is the probability? Why are you trying that? You know, it's not de-energized. You did not de-energize, you did not switch it off, even though it's still a wrong practice. But now you're actually we are doing the evaluation of the risk on it. What will be the probability of you receiving shock from your socket?
It will be low.
Medium.
It will be low.
Low.
Okay, I agree with that. Now, eventually, let's say you now receive electrical, accident. There's an electrical accident on it. What can it do to you? How severe will it be? Will it be low, medium, or high?
Low.
It can be medium.
It will be low or medium. It will be depending on the resistance of your body.
Okay. You got me laughing. The resistance of your body.
Okay, please let's be organized. If you want to speak, just indicate, signify rather. I will call you.
You will tell us how to calculate the resistance of the body. But look at that. Your socket, your 30-amp socket, okay, actually fall on this place. So somebody is actually doing that. I'm not encouraging that. But we are just looking at it based on what the risk evaluation. Okay. Somebody working on this might just say, oh, let me quickly connect it, and you might actually say you are doing that, but you can't try that with all these 7.5 kVA transformer and all that. That's what we are saying, because the probability is high, the severity is also high. Now let's look at types of electrical accident. These are the types of electrical accidents. Shock. Okay. Anyone here? Go to the comment section if you have received electrical shock before. Okay, I know it should be almost all of us. Electrical shock, just type yes. Let's make this lively. Electrical shock. Anybody? Go to the comment section. Can you see my screen? Yes, electrical shock. Of course, we have regular customer here. Shock. Everybody is saying yes. Okay, let me step it up. So let's look at the second one. Bonds, electrical bonds. You have added bonds due to electrical, fault before. Maybe you touch a very hot metal. Okay, let me analyze them first before I ask you. Let me take them one by one. Okay. Let me take them one by one. Okay. So if you have added bonds before due to electrical, type yes. Can you type yes? Let me see that. Anybody that has been burnt, you felt the burnt of maybe there's electrical burnt, maybe hot. Yes. I have some yeses here. Okay. No burns. Okay. Anybody who has witnessed fire incident due to electrical spark or fault before? Anybody here? Electrical, yes, fire being energized by electrical. Oh, a lot of yeses here. I won't say that's great. It's not something to be encouraged. Explosions due to electrical spark. Explosions. Type no if you have not witnessed it before. Explosions. Joseph, are you saying something else? Joseph, can you unmute, please? Mr. Moderator, please let me call Joseph out.
Yeah, I'm here.
Okay. Did you say yes to explosion?
Yes, I actually witnessed one.
Tell us how it happened.
I don't know what really happened or what really caused it, but it was a very loud bang. So it was scary, and there was fire everywhere, as it was fireworks on top of the electric pole.
Wow.
And it was really bad. It wasn't a sight to behold, honestly.
Wow. Thank God it didn't happen to you. You saw it happening to someone else.
Yes, so God.
So,
it was really scary, honestly.
Thank you for sharing. Okay. Arc flash. How many of us guys have felt arc flash before? I need to bring up something on that arc flash. Let me think I have something on arc flash. Something is also very scary. You must have, if you have worked on a two very loaded connection before. So you can see arc flash incident. Can you see on my screen what I'm displaying? Look at this. Look at that. This is a result of a arc flash. Okay. Okay, you just see it just come like an explosion. That one will also come like a flash of light. It does happen sometimes. If you have done it before, if you use the red cable live wire to touch the neutral wire, you must have seen what I'm talking about. What maybe mistakenly they touch each other in your presence. Then you see, you can see.
I have witnessed all of them.
You have witnessed all of them before. That's not fantastic. So now let's mute, please. Mute, please. The last but not the least is what? Falls resulting from electrical injury or incidents. And this happens a lot when you are doing what? Electrical work that has to do with what? Work at height. Falls, when somebody fall off due to electrical work is a scary sight. It's not something to witness at all. Now, I want to just show us, for you to see the effect of you know, electricity due to the measurement of the what ampere rating of them. You can have a tingling sensation, just a tingling sensation. I know many of us must have felt that before. It will be as if the electrical, you know, the current is massaging your finger, you know. The feeling may not travel beyond your finger. So if the current rating is between 0.7 to 1 microampere, okay, if you have milliampere of 0.7 to 1, what you will just feel is tingling, you know, just tingling sensation. Okay, slight shock. You can have a slight shock, but not a painful one. Okay, you may not lose your muscle control with it if you have experience. If you are exposed to 1.2 to 1.8 milliampere of what current. Okay, shock, a painful shock this time around. Okay, but yet your muscle is still what secured. That's when the current is up to 6 to 9 milliampere. Okay, shock now, not just painful, but a severe one. You feel that there will be muscle control loss, there will be breathing difficulty. Okay, there will be onset of let go threshold for you also. Like that's when you get exposed to 15 to 23 milliampere. So you can see this possible ventricular fibrillation. Okay, that's when you are exposed to about 0.1 ampere, okay, of current. So you can use this to know when you are working on equipment, like the first person that answered the question when I was asking about how do you differentiate the 13 amps and 15 amps, the brilliant answer is that what all equipment, when you take your time to check them, you see the current rating on them. And with the knowledge of this class, you can see what you are open to. If this should actually what come in contact with you, or you are exposed to it, what should you expect? That's what we are talking about. So you should know the one that can give you what? Just a tingling sensation, the one that will give you slight shock, the one that will give you what? A very big shock, not painful, severe shock, possible ventricular fibrillation, possible heart muscle activity seizures. Okay, seizure of what? Heart. You should also know about that. That's the one of 0.5 what ampere rating. Okay, and tissue and organ burn is the one of 1.5 what ampere. So when you look at what the current rating, you should know what the extent of danger that could actually what occur to you. So I have them being itemized here, so you can see what is the what effect on person. 0.5 to what 3 milliampere, tingling sensations, 3 to 10 muscle contractions and pain, 10 to 40 milliampere let go threshold. If you have felt down before, that's you wanted to actually what to drop the cable, but it will just be as if you know you are magnetized. For those who are deep into electrical, you'll be talking about electromagnetism and all that. You know, like an induction. It turns the conductor to an induction to magnet, to a temporary magnet, and then for you to let go would be very, very serious. So I think I've actually experienced that before. I've experienced that before, and when you come out of that, it's just it's just the grace. Though my own was actually domestic, I've always been very careful when it comes to industrial safety. I've always been very careful, and the one that I even experienced domestically was very, very many years ago. Even before I got to have a deep knowledge of electrical, I was still very, very little. So I'm talking of many years ago, but I still have the memory is still fresh because it was a very terrible experience. But I've always been taking my electrical safety. I don't take it with a joke. And that's what we are actually doing with this training. So the bonds can be thermal contacts. So when you have your skin, touching the overheated electric conductors, this can be from your hot plates, or if you have any hot, an electrically powered hot metal or hot equipment in your place of work. For example, in my own place of work, even though it is not electrically fired, but there is a lot of electrical equipment that is working with it. We have kiln. That's in cement plants. We have kiln, rotary kiln. We call it rotary kiln. Okay, and when it is fired, you're having about 1,000. It is fired up to about 1,450 degrees Celsius. To the extent that when you are passing under it, you are passing, the rotary kiln is always very high up. When you are walking beneath, you will feel, even some meters away from it, you will feel the radiation of the heat. Okay, so these are thermal bonds. If you suffer bonds due to this, if they want to maintain the kiln, they shut it down for like 4 days. It's still cooling down. Nobody can go near it. Okay, so electrical bonds also, we have electrical current flows through our tissues. When electrical current flows through your tissues, there will be bonds, and the skin deep or affect deeper layers of your muscle. That's electrical bonds. We have arc bond. I just showed you arc bond here. Okay, in this diagram, you can see arc bond. This is bonds. Look at this palm. The person was actually working. So you just hear this one is just like the way you see those people that do welding work. Okay, when you see that light that is coming out of them, so the arcing light is like that, and then it just comes like that, and then you have the bonds. Look at this person's armpit here, the arm and everything. That's a serious bond here due to what? Arcing. And you must note that what? The three of them can happen together. You can be exposed to what? The bonds due to thermal contact, due to what? Electrical, and due to hacking. The three of them can actually what? Happen all together. So hazards. Let's look at the controlling hazards. So we should know that what? You can control hazards, and you may also, let's say that you can minimize the risk, okay? Number one, by creating a safe work environment. It is very important. If the work environment is safe, you will be able to overcome a lot of hazards. Okay? If all the connections are properly done, you can overcome what? Electrical hazards, a lot of them. If the floor is not wet, you can overcome a lot of electrical hazards. If the equipment are, all the electrically energized equipment are properly what? Covered. Okay, when you have their cable being joined together, it's just like you having your junction box at home without being covered. So there are situations that when you get to plants, for people like me who are in the field of safety, that goes into company and help them to look for loopholes of their safety culture. So we check it for them, and then we tell them, we recommend, oh, you need to improve on this, you need to improve on that, you need to do this, you need to do that. For some of us that do that, you will see that your awareness of what? Electrical faults or things that are not right, your awareness will be very, very high. So when we walk around like that, we can easily spot things that are not being done right. Oh, this is not good for your work environment. Can you change this? Can you replace that? That socket is most of the welding sockets in some industries are not properly installed. Okay, most of the equipment are not properly plugged in. If they are not properly plugged in, this can increase. It can generate more heat than necessary. Okay, if some cables that used to connect some equipment, due to their current rating, if the cable cannot support them, you should be able to know that there will be overheating through the cable, and in a very severe condition, this might actually generate the cable can get burnt along the line. So the work environment is a sensitive place. that you need to first put everything right first. So if the environment is safe, you can guarantee that 75 or 80% of the electrical accidents that may occur can actually be mitigated or minimized or controlled. Using safe work practices. What about the practices of work? If the regulation says for every electrical worker you must use your hand glove, then you should know that using your hand glove becomes very, very paramount. You must not be seen. It's just like the health workers. Before you can attend to any patient, you must put on your surgical glove. That surgical glove is to protect yourself from germs. You also, as an electrical man, you must use your glove. If that is the regulation of your company, do not say that this one cannot touch me. I'm very confident. How many years I've been doing it, nothing can happen. I will touch it. I've even heard of people, who can actually place bets on the fact that they can. I don't know how they got their own experiment, or maybe they found it in a physics textbook or anywhere, that when you seize your breath, electric shock you can't feel electric shock. That's a very dangerous idea. Unproven hypothesis for anybody who wants to uphold electrical safety. For you to say that you are going to touch a light cable, you seize your breath and nothing will happen. That is wrong. It is not a correct practice. So the practices must be right. If we say that people must take line clearance before they can go and work on equipment, like the story of that my friend I shared with you, you must adhere with that rule. Violation to that rule should attract punishment from the company, management. In the industrial management should frown at anybody. Even though you have done the work, you escape the risk, nothing happened. That doesn't mean that if you continue like that, it won't happen one day. So if you must wear your glove, wear your glove. If they say this place, helmet is needed, wear your helmet. So that is what we talk about. The best method is for you to keep a safe work environment, for you to actually uphold the safe work practices and being properly trained. That's another problem. In most cases, we assume, I already mentioned that from the beginning of the training, that induction in every company is necessary. How many of us went through induction in the company where we work? If you went through induction in the place where you work, can you please go to the in-messages and type yes? Was there an induction for you, like a proper orientation? I've seen only one person, Charles. Is there another person? 2, Popola, Joseph, 3, 4, Adex. Okay, great. There should be, I don't want to know where you work. So that, so many people will not start writing applications to your company, and then they want to take your job. So proper orientation is very important. People need to be trained. People need to be trained, irrespective of the experience they are coming from. Even you that you are raising your hands, if you should leave your company today and go to another company, it is very, very, required that you should also still be trained based on the environment where you are presently working. So, limit exposure. We are talking about you should reduce the amount of time spent around high energized equipment. It is very important. So you should limit your exposure. The time interaction should be very, very low, should be small. Maintain distance. When you have a highly energized equipment, you maintain distance. You need to know that when you have transformers being installed all around in your company, you shouldn't walk too close. Many of us, in the theoretical aspect, I don't want to go into it. There are eddy currents, there are flux linkages that can actually happen around your transformer. So you don't need to, most of the accidents and deaths from transformer that I've heard of, even the person doesn't need to touch it. Okay? In high tension, there is what we call corona effect. Corona effect. That's to tell you that what all the air that are around the what and electrically what energized conductor, all the air that surrounds it, they are ionized. They are also charged. They have turned to charges. So that's where you'll be hearing the sound when you pass through your in front of very close to your transformer or any high cable that is carrying what high voltage. You'll be hearing all me sound like something like that. That's what we call corona effect. Okay, so you should maintain your distance. Okay, when you are walking, you can also bring what a particular mass in between you and the equipment in case there will be explosion. And if it is required in your company, then you need to wear your PPE properly. You need to learn how to wear your PPE properly. In fact, I encourage people, even if your company did not give you, you can actually get some for yourself so that you can keep yourself safe. It is very important. Now, let me quickly talk about this before I allow questions and all that. What are the protections against electrical hazards? The first one is the insulations. You can use insulations. I've talked about that. Insulations are poor conductor of electricity. So if we coat or we cover a good conductor with a material that cannot easily conduct electricity, so that material that cannot easily conduct electricity is called insulation. So one of the ways you can actually achieve safety is for you to, cover a good conductor with a poor conductor. And that's what you see your plier. You can use your plier, to twist live cable together, because the angle of your plier, okay, the place where you put the effort of your plier, it is actually insulated. Okay, and it is not even ideal that you use it to twist live cables. I'm only saying that it's actually the insulation was placed on your plier, so that in case you don't even know that there are supply there. It's not meant that you should really be using it to twist live cables. I've said it time without number that you should try to work on a dead circuit. Do your best. If you can actually shut it down, let it be that you're working on a dead circuit and not energized circuit. There can be guarding. Guarding means that you can provide a guard around the equipment, so that your hand cannot touch the cables, your hand cannot touch the live cable or the exposed part of it. You can put a guard around it. Grounding, you can connect the body of the equipment to the earth. In case there is leakage current, then it flow to the earth. The grounding is like creating a part of low resistance, to the flow of current. And you know that current will always be attracted towards a place where there is low resistance to it. Just like human being also, you would like to go to a place where they are not pushing you back. So if you have a part of low resistance for the electric current, you can save the other body, which is you in this case. So we can connect to the ground, because ground is a very good conductor of electricity, and it has a very low resistance to the flow of electric current. And we have electrical protective devices. Those are your devices that can help to safeguard, in case there is maybe an overload, okay, or a short circuit. We're talking about your fuses. The fuse can blow out, therefore discontinue the flow of electric current, and then there is safety. We have circuit breakers. Many of us have these. You are interacting with it in your industry, or even in your household. We have we have a grand fault circuit interrupters. We call it GFCIs. So what happens when there is what? The grounding fault, earthing fault. So these interrupters are the ones that will actually help, okay, to still save what? The equipment, or to save you from what? Being what? Electrocuted, or being exposed to what? Electrical what? Accident or fault. So let's peg it here. We have a whole lot. Tomorrow we will pick it up from where we stopped. I'm going to be diving into the electrical safety, talking about what the PPEs that are needed for you and how you should properly wear them. We are going to be talking about what Lotto itself, log out, tag out. I've mentioned some part of it today, but what are the necessary steps and procedures that are needed for you? And tomorrow I'm going to be dealing with what? Fire safety. Also, what are the required what skills? Okay, the required what techniques from you in case there is what fire incident resulting from what electrical, source or electrical fault. How do you fight this? And so many other things that we need to actually what cover. So everything will be covered tomorrow, talking about what energized electrical work permit and all that. So we'll be discussing all this tomorrow. So I hand you over to the moderator. So if there are any questions for me, thank you.
All right. I want to appreciate our resource person, Mr. James Paniyi, for that very, very engaging and wonderful class. Yes, Mr. Gimba. Okay. So quickly, let's go to questions. A whole lot has been discussed in today's class, and yes, these are pertinent action lessons that we need to take hold of and begin to implement. Yes, as far as our workplace is concerned, and as it relates to electrical safety. Okay, so let's take questions. So please, if you have your questions, just signify by raising up your hands. So I will call on you. And those who are on the YouTube platform, if you have your questions, please drop it in the comment section. So we'll take it up from there as well. So please signify by raising up your hand. Just raise up your hand. So I call on you for your questions. Let's do that quickly. Okay, thank you very much. I can see Abel Elijah Onoja. Mr. Abel, you can unmute your mic. Mr. Abel, we can't hear you. Okay, maybe I'll come back to you, Mr. Abel. Let's go to Udoji Sylvester. So, Mr. Sylvester.
Thank you very much. God bless you all. Mr. Speaker, I really appreciate your terms and your language, your terms of a professional speaking. I cherish it a lot. It's in fact, you have really exposed us to some of the minor risks that we usually take while carrying out our several jobs in our different work areas, both on side hustle aspect and industrial aspect. Yes, I am a mechanical person, and I do more on electrical. And for you to be a mechanical person, you need to have a good knowledge about electrical, because most of those mechanical machines are being operated by electricity. And again, I was also born into the home of electricity. That's by hereditary. So I also carry out some electrical work where I have both domestic and industrial. So I also have that skills. Thank you. I really appreciate you. Well, mine is not really a question, because the aspect that I intend to ask a question, he said is going to be for tomorrow, which is that really the aspect of that Lotto. So there's a lot of things there that we really need to understand. I just want to appreciate him and tell him kudos. Please, these slides that you use for this presentation, how are we going to get it? Are they going to be forwarded to our email, or is it going to be forwarded on daily basis, or after the end of the lesson? That is my question. Thank you.
Okay. Thank you very much, Mr. Sylvester. Okay. Just a minute, please. Let me stop this. Okay, yeah. So I appreciate your comments and your comments regarding the class so far. Yes, and regarding your question, yes, we are going to be sending the material alongside the certification for the training. So I'm going to talk more on that. Yes, definitely we are going to make the materials and the recorded videos available for everyone to utilize. Okay. Okay, thank you very much, Mr. Sylvester. Okay, so Mr. Abel.
Thank you. God bless you.
Can we get your question, Mr. Abel? Mr. Abel, can you hear me? Okay, so what I think you should do is you can drop your question in the comment section. Okay, let me see. I think yes. Okay, Emmanuel. Okay. Okay, so I was thinking that's a question. Okay, so any other question? Do we have any other person with a question? Any other person? Okay, Ilega, Iria News. Pardon me if I didn't pronounce that name correctly.
Okay, good afternoon. Good afternoon,
yes,
everybody.
Good afternoon. Please go ahead, sir.
Okay, please, firstly, I would like to commend the convener, which is you, Cecil, and the speaker for a very good presentation. I just want to ask, how, are we going to get a certificate? You know, in the Nigeria workplace market today, certification is very, very, very important. So I don't know, after the end of this course in particular, we're going to get a certification. Is it free or we are going to?
Yes, I'll speak to that in a bit. I'll speak to that in a bit after we see all the questions. Okay, thank you, sir. Olodua Joshua, I can see your hand. Olodua Joshua.
Okay, sir, can you hear me, sir?
Yes, please go ahead.
All right. I quickly want to ask, on YouTube, can we go back there to check it up? I mean, this presentation or this class that was live on YouTube, can we go back there to always check it again, or will it be available there every time?
Okay, thank you very much for your question. Yes, the YouTube video is going to be available. Yes, so you can go back to it at any time. That's why we have it there, and that's why I would advise that you subscribe to our YouTube channel so that you'll be able to access those videos. Because there'll be at a point in time whereby the only people who subscribe will be able to have access to those videos. So just do well to subscribe. But for the moment, you are going to be able to access them unrestricted. Okay, so we have thank you, Mr. Olaoluwa. So we have a question in the comment section from Jimba. What are the different colors in the analysis of risk charts, evaluation of risk? Okay. What I suppose you are asking about the different colors we have as it pertains to the high risk and medium. I think that's what those colors are trying to identify. The points where you have high risk, there's a color that is signifying that. I think that is red. The points where you have low risk. So I guess that's what you're asking, but I will leave that to the resource person to respond to in a bit, actually. Okay, and those, okay. Okay, so thank you very much, Mr. Jimba. I saw one other person. I think the person is, okay, so that's the question. Those are the questions we have for now, but let me allow the resource person to respond to the, I think, one or two questions that we have. Then I would give the closing remark. Okay, Mr. James, thank you very much, sir, for the class so far. Over to you, sir, so you can give response to those questions.
I think I only have one question. Thank you, Mr. Kenny, for that wonderful ask. So the question I have is about the colors that we have for, let me say, hazard identification of hazards. Although sometimes you should know that this may actually vary from industry to industry. But however, we can actually pinpoint some that seems to be common one, but it may actually vary from industry to industry. So depending on what the industry is doing. So let me just give you some that are just common. They are just common color coding system that we have. So when you see red most times, it actually depicts maybe fire hazards or anything that is high risk situations. So the risk is very, very high. It's considered very, very high. When you see yellow, yellow means caution. It means warning. It means that you should take note that there is a potential hazards in that particular unit. So that is yellow. So it's just like a warning color. When you have orange, orange also mean warning, caution, but this it's actually quite much more specific than yellow, in the sense that where you will see orange being used maybe in construction, in maintenance. So orange is much more specific warning, while yellow is generic in warning. It's just showing you that, oh, there is a potential hazard in this place, but the orange will tell you the particular hazards that you have been warned on. So that's the uniqueness of orange as a color. When you have green, of course, when you see green, so safety, first aid, emergency equipment, it just means that perhaps you can access that particular place, okay, but there are some conditions that may be attached to it. Maybe you should just put on your helmet, you should wear your glove and everything. But green means like you can go ahead to access that particular unit, but that doesn't mean that you should take off your PPE and all that. So these are colors. We have, we can go on and on. We have blue, okay, so on and on you can go. So those are the color system, common ones that we have. But pay attention to the industry where you are working, okay? Pay attention to the industry where you are working to know some differences that we may have. So Mr. Moderator, I think that's the question I have. The rest are your questions. Will there be materials? Will there be certifications? Will there be this? So except you want me to give a generic remark when you are done. Thank you, sir.
Okay, thank you very much, Mr. James. Thank you for the succinct response. Okay, so regarding the certification for this training, yes, we made provision for the certification. So for everyone who is interested in certification for this course, which I expect that, yes, you try as much as possible to take this opportunity that we are giving. The firm has decided to give out the certification for this course at a discount rate. So that information will be dropped at the end of the training, which is tomorrow. So you have that information, or possibly it can be dropped tonight. It will be dropped on the group. So it's not something that you need to break the bank for. So just try as much as possible to take hold of that discount offer that we are giving. Yes, we have series of training that just ended, and many people participated in that training, actually benefited, from the same discount offer. So, and this is not going to be an exception. So please take it. You have a limited time actually to key into the discount offer. So the information will be dropped on the WhatsApp group at the end of the class, or if not today, then you'll find it on the WhatsApp group maybe tomorrow. Or just know that, yes, it doesn't disturb you from attending or participating in the training. So once we are sending out the certification for this training, we are going to be sending out the materials. The recorded video, everyone who has registered for this training can access it. The YouTube platform is open. So please, when we finish from this class, just go on the YouTube platform and subscribe to our YouTube page. There's a link that we use for the live channel. You can use that link to access our YouTube channel as well. So just click on the subscribe button. We have lots of videos. Industrial machinery maintenance training that we just concluded. The videos are still there on our YouTube platform. Those who are interested in project management, the videos are there on our platform, still very much accessible, and many other courses like that that you can access. So just take hold of that opportunity and explore, our channel. Okay, so I think I've answered the pending question. Okay, so without further ado, let me look for Funke Telma. Please, yes, we'd love to get your feedback of the class so far. So on behalf of the whole class, before we dismiss from today's class, Funke Telma. Okay, is Funke Telma there? If you can hear my voice, we'd love to get your feedback of the class so far. John Oladejo. John Oladejo, can you hear me? Okay, so I guess majority are busy. So what we are going to do is, please, when we dismiss from this class, let's go on the WhatsApp platform, drop your feedback of this class so far. Training continues tomorrow. We are not ending it yet. Tomorrow, same time, 2 p.m. to 4 p.m. We are going to continue with the day 2 class. And please don't miss out of that class. At the end of tomorrow's class, there's going to be assessments. Yes, assessments on everything that has been discussed, that has been taught in this class. So please bear that in mind. So for you to be sure that yes, you have passed this assessment, you must do a 60% performance in it. And this is also a requirement for you getting the certification. So please prepare for the assessment. It's not going to be difficult. It's not something outside all that has been taught or covered in the course of this training. So please, let's prepare our minds for that, which is very important. So please drop your feedbacks on the WhatsApp platform so that everybody who couldn't participate in this class can also join in tomorrow. And if there's anyone who is not into this class, let them rewatch the video. We'll be dropping the YouTube live link again on the WhatsApp platform so they can reassess the class from there. Okay, so thank you very much, everyone, for being a part of today's class. I'm so excited that, yes, I'm meeting these new faces. So, yes, we are still going to be meeting here tomorrow, same time, same classroom link is what we are going to be using. So, till then, I wish you a productive and sweet night rest. Yes, because it's now everyone is returning back to their homes. Okay, so thank you very much, everyone. You can unmute your mic and tell me bye-bye.
Yeah, goodbye.
Bye.
Yes, goodbye. Goodbye. Thank you.
The training is nice.
Goodbye, sir.
God bless
Goodbye,
you.
sir.
See you tomorrow.
Thank you so much.
Bye-bye. God bless you.
Bye.
For that training, I'm highly interested in them.